which is the sound bouncing into the material and going back. So you do get some standing echoes, we call them.
Now, how do you know the angle is 0 in this? Right?
Because I set it up to be as 0. So if we go to the wizard, let's start setting it up, for example. So I'm starting it as, so here it is asking me specify dimensions, material, geometry of your part. I've got it as thickness 100, which is what I think that is. Material steel, so it knows the velocity of the sound in that material. It's a plate specimen. It doesn't have a weld in it. Now we'll start setting up. Okay, that was the part. If we go to the setup, we will set up what the probe is. So, okay, modify phase array group 1. Okay, this is to give names to your groups. Select a probe. So this is a 2. It has got it in the library. So this is a 2.25 L32 probe, and it's a good thing that we started again because it says wedge contact. So it doesn't know at the moment that it's got this. It thinks it doesn't have it, and it's in contact mode. So if I go to the wedge library, I can select the N55S. So now this will input into the, it shows me already, it's a 36.
Oh, so the name of that part is N55.
Yeah, so it's writes on it N55S,
Okay.
S31 N55S, which is not, let's say 31. So now it knows the dimension, it knows that distance, which is important for it to know.
The angle 36.
So it can show me exact. So now it knows when the beam will hit that interface. So it sets this as 0. So in the depth measurement, in my depth measurements, I will have this as 0. Otherwise, I would have this as 0, which would be wrong. So now it knows what wedge I've got, so it can calculate how to generate the right angles. And this is the low configuration, so this is a bit too complex to. So this is how many elements it's using at any one time. Now it's using 10 elements. So only the first, it will use the first 10. And the linear low means that then it will increment. First time it will use first elements 1 to 10. Second time it will use 2 to 11. Third time it will use 3 to 13.
Yeah.
And it will increment one element at a time until it reaches element 32. So it will give me, you will see, so it will give me many beams in one. So first element 1, last element 32, element step 1. So it will do 1 to 10, 2 to 11, 3 to 13, and an angle of 0. So I want it to give me an angle of 0 for the moment. Then we will do focus depth. I'll change that. So I'm telling it where to focus. Yeah, leave it and focus. How deep to focus, try and focus the beam. Index offset, and this offset is to tell you tell it where the 0 on this axis and that axis is in its measurement. Let's leave it at the center of the probe. So now it's generating the beam. So here, hopefully, if I was looking deep enough, so this is looking down to 70 millimeters depth. That's why I see nothing. It doesn't reach, my screen doesn't reach the bottom. So if I go to UT settings, that range, we start seeing the bottom of the, let's leave it at 100. And if I add, so then you receive a signal back, but then you need to amplify it because it's very weak, as you see here. It's very weak. But I am not using many elements, so I'm getting a very weak signal from the backhoe. And also because I'm using a wedge that is not for 0 degrees, it's for an angle, I'm getting some standing echoes from the wedge, which is not good. But I'm not using the optimal, where I just want to show you a 0 degree. For example, let's use now more elements, and you see it will be better. So I won't do the wizard again. I'll do focal law, aperture, element quantity. Because when you've got a very small, so when I'm using only 10 elements, for example, I've got a very small probe sending signal to the black hole, so it's quite a weak beam. But now that I've strengthened the beam a bit, I get a much better response from the black hole. So now the challenge is, tell me when you see a defect.
Yeah, it's a different one.
Yeah. So that is that hole here, as I'm going over it. But as I say, because I've left my beam unfocused. If you remember earlier, I put unfocused here, and that hole is at. So that's wrong, obviously. It's not at 45 mil depth, unless I see this and don't see the hole, which is I think what is happening. Yeah, no, that's the hole there. Okay. That's the hole there, and that is.
That's the
circle.
Okay.
So, but if I focus it, because now I've got it completely unfocused, and the beam might be focused down there. If I focus it at 20 mil or 30 mil depth, which is close to where the defects are, you'll see this image becoming more with a better resolution. See that hole became a bit better. Still not perfect, as I'm using a zero beam with a wedge that is trying to steer the beam. So I'm trying to create a beam down there. It's not optimal. But you see that you can see when there's something wrong. So when there is no defect, you don't see anything. I just move the probe, you don't see anything apart from the back.
Yeah.
So, it will become a lot better when I'm creating angles in it that match what this wedge was designed to do. And now I'm trying to get it to do something that it doesn't. It's not
supposed
meant to
for
do.
Yeah.
No. So if I load my previous setup, and let's not load it. Let's create it. So part is the same. Let's change the setup. So. Okay, leave that the same. Probe and wedge are the same. So all I'm gonna change is use a sectorial scan, which is the scan that you can set up different angles, or set a sector. I've not spoken to you about waves yet, shear wave and longitudinal wave. We might do that in the end. Usually at an angle probe you use a shear wave with 0 degrees. You've got only a longitudinal wave. How can I easily explain that? Leave it for now. I'll do it later. So we'll use all the elements now with a minimum angle of 40. So let's start our beam at 40 and take it up to. See, it's adding beams. Take it up to 70. About 40 to 70 are about the limits we can use in terms of angles. Because below 40, the shear wave becomes a longitudinal only wave. And above 70, it starts becoming a surface wave. So there are limits in what angles we. So we'll have an angle step of 1. So it will create 30 beams at once. Focused. Okay, leave it at 30. That hole must be at 15 depth. I'll leave it at 30. It will still be okay. Then when we turn it around to look at this corner here, for example, we'll set it to focus deeper. Okay, if we generate here now, you will see on our screen, we'll get a range of angles, starting from 40, going all the way up to 70. And we get for each of these angles an A scan. The A scan is this. This is the raw signal coming back from only one angle. Now it's that angle that's flashing, that cursor that's flashing there. So that's only the 40 angle. If I move it, you see that changing? So that's taking a cross section or the amplitude from that angle, from that line only, showing me there. So if I move that angle over that, you'll see a very strong signal on the A scan. See that? So that is that. That is that.
So this is the distance. So
Yes, that is the true depth now. So that's something at 60 depth.
so something at 60 and
Yeah. If I had a ruler, you would see that this. It's either the beam hitting. It's possibly the beam hitting the radius. That. It's because the beam is coming from there. It will hit that radius. It will hit that radius only. It will get a very strong response only at the time of the position of where that radius is optimum to give you the reflection back. So the positions where it hits the radius there and the beam goes there, or there it goes there, you don't get a strong response. So you get a very strong response only from the part of the radius that is aligned from the tangent, whatever. From, you know what I mean? Yeah. From the tangent of the radius has to be perpendicular to your beam.
Okay.
That's where you get a very strong response. So as I move back, that response is coming from different angles. See that? This is all from the radius. So now almost my 65-degree beam that is traveling down there, it hits the radius somewhere there and coming back. But that remains at the same depth all the way along at 60. Or it will move a little bit because you hit it at different depths, but it doesn't move that much because it's always that radius. You do get it, that's why it's not always trivial to be dealing with ultrasound, because the sound would bounce onto you, would bounce in the material. So you would get
like because of the grain structure of the
No.
material, it bounces.
in carbon steel is very, very clean. It has got very small microstructure.
Fine.
The sound is bouncing off that, up there and back again, for example. So, or it would bounce. So it's bouncing continuously. That's why you need to sort of, when you see something, you need to understand where it's coming from. And now I've got too much gain in, because now I reach this area where I get a response from. I do get a response from the small hole, which is this up there at 15 depth. Let's clean it up a bit. That's why also another. Sorry. Another very important consideration: how much gain you put into the signal, how much you amplify the signal. If I've got it, come on. If I've got it very amplified, I cannot find anything. All I see is noise. That's why we calibrate the equipment. I think what I'm also getting is this is creating like repeats. So calibrating the sets or your inspection. So this hole is a calibration hole. So we would set that, for example. We would have many of these, as I showed you in the presentation. And you would set all these, for example, to reach 80% full screen height. So you will adjust your full screen height is a term we use, but it means that 80 there. So that signal to reach. So you would adjust your gain so that this reaches 80. And then you will do that for the next hole along the depth. And then you will save that calibration, so all the holes along the depth of the same diameter will give you the same response. So when you go and scan and you get something you find a defect that has got 80% amplitude, then you say, okay, this is comparable to a 2 millimeter hole in size, for example. Sizing wise, you would see if you measured how. I realize this is difficult to see if you do not. So if I make it, all right. So I've zoomed in a bit. So if you measure where that signal starts or where that maybe yellow starts and finishes, it will be about 2 millimeter, which is the size of this hole.